Hello, how are you today? This is about displacement maps today. And you see this landscape, which could have been deformed by geometry deformation. Lots of detail in that plane, with lots of faces being pulled up and down, and would have been work of, well, 2 or 3 days to actually deform geometry here in such a way that it looks that detailed. The second way to deform a surface is not actually deforming the surface, but planting an image onto that surface and let Maya or Arnold render a bump map. A bump map simulates deformation, but it's actually not doing any deformation to the scene. And the third method is what this tutorial is about, and probably a future tutorial as well, with a more sophisticated displacement map. This is a displacement map which basically is like a bump map. I put a picture onto a geometry and then I define it as a displacement, which makes actually the black and white contrast turn into hills and valleys. In order to see if this is a bump map or geometry or a displacement map, we need to run this animation here. And now you see here the mountain is sort of coming up. You see this rim is actually not a painted or whatever rim, it's an actually geometric rim. Here you see the bump now. It's not a bump map, it's a displacement map. So the surface parts are really displaced in these areas here. And here, for example, this could be a bump map because we're not that close. If we get close, it will turn out as a displacement map. Let's go further over that hill. Here you see this is a real poking out. You need to change the what they're called Cat-Clark settings, which we'll touch later, in order to get this more round. And here we go down into the valley, and here you see actually deformed geometry, but we did not deform the geometry by hand, we let the displacement map work. Let's rerun it once more, and then I jump into the next part of the tutorial. By the way, you see the watermark Arnold here in the background, because this is the student version of Maya where you can try out everything. It's fully open, but of course there are some restrictions with watermarks, etc. And the playback here goes via fcheck, which is a very nice little tool which has been integrated in Maya since the beginning, since version 1 actually. So this is basically a very simple geometry, a torus. It's not high res really, and I rendered it using a bump map and a displacement map. This is a displacement map. If we get closer, this is what is being displaced. It's actually an up and down. It's a hill structure. Here we can't really tell if it's fake displacement or bump mapping. Or real displacement, if this is really going up, if we would get closer. But the difference is quite obvious. This is the bump map. The bump map pretends that this is 3D-ish, goes down or up, depending on how you look at it. It uses the light in the scene and creates shadows and highlights. But at the rim here, you see it's fake. It's all fake. And from a distance, the same thing. This is a close-up of this one. It looks perfectly 3D-ish and like bumpy. So it works with the light here, more reflections here, more black here. So you get a real impression about the lighting situation in the scene, and it looks so sophisticated now, but it isn't. It's just a bump map which is faking light, as opposed to this one, which is a displacement map, which could have been created with deforming actually geometry as well, but we would have needed a much higher resolution for that. So let's get into a new scene now. First of all, for displacement as well as for bump mapping, you need a texture. It can be a procedural texture like a checkerboard, but I want to choose a photograph here. And since I enjoy doing little planet photos currently with a 360-degree camera, I thought I'd just check Google for pictures about little planet photographs. So this is a German search engine of Google. Bilder means images, so I search for images. And here I chose the license. I want to reuse this image, so I checked the reuse option here. So all the images here displayed here are reusable. And I also clicked here, that's the size of the image. Big or large, probably in English, means it's not the 500 pixel photos, but larger. And for displacement mapping, we need large format photographs. They make much more detail in the displacement map. So I thought this one was nice here, for example, in the Wiki Commons here, 1100 pixels wide. But even more detail because of the trees is here. And it's 2000 pixels wide, so I downloaded that. The image is here. It was photographed in 2012 by Rolf Ackermann. So my appreciation, he uploaded this for free here onto Wiki Commons, so we can reuse it now. It's actually a tiny chapel or church in Würzburg in central Germany. Very nice Baroque, rich with gold, and very, very Catholic. I quite like that church. I've been there several times. So, but now I'm here because of the trees here, all the little branches. Okay, I downloaded it and put it into the source image folder of Maya, and now we can close this and create a polygon plane, for example, to start with. Here in the polyplane 1 options, I set the width to and height to 100, so it becomes larger. I deactivate the grid because we do have a grid already, and in order to see displacement maps properly, it's always nice to have a little bit of deformation here. So with this surface picked, I go to the deform menu. It's under modeling, I guess. And here I choose sculpt. The sculpt deformer starts like this. It's tiny, and it comes with 2 nodes here in the outliner. One is the sculpt stretch origin, and one is the sculptor. So if I scale it up, the sculptor that is, that's what it does. It does nothing. And if I move the sculpt stretch origin down, we see an effect up and down like this. It makes that little hole. I actually want a bump upwards, so I scale the node a bit larger, and I move the origin further up. Now I select both of them and move them a little bit down like this, so should be fine. Maybe a little bit forward or whatever. You see? That's all for the deformation now. Now on the surface here, the polygon plane, right mouse click, assign new material. Because displacement is about a material, go to Arnold and AI standard surface. That's a standard Arnold shader. We don't want to have it shiny, so we lower the weight of the specularity to 0 basically. If we render it, we see nothing, but we can add a sky dome light, and that's what we see when we render it. It's pretty bright, white surface. Okay, now where do we put in the information about deformation? Certainly not in the light, so we have to pick the plane again, and we have here the standard shader. Actually, I can select it. Now, where in the shader do we put in the displacement information? We have no Arnold section here, and the reason for it is because this is an Arnold shader anyway, so it's Arnold all the way through. Well, how about clicking here? This gives us another aspect, which is called AI Standard Surface Shading Group. Very interesting. We could have done it in the Hypershade as well, but this is quite practical, I think. Here we have the surface material, which is the current shader, which is the white surface here. And we have the displacement material. And here we click in order to add a displacement. It asks us what kind of displacement we want, a checker or a grid or a mountain or whatever, but of course we will pick a file. The file is here, and I think this is a little bit too much. They should improve the user interface here, because now we see no way to put in to link the shader to the source image we've just downloaded. But we can go to File here, and here it's the image name. We click on the folder, and we have here the little planet in Würzburg, and we open it. Don't worry, you don't see a displacement here in the viewport, at least not with my graphics card, and my graphics card is not the worst. I think it's about €600 because it supports virtual reality with the HTC Vive, but I can't visualize displacement map here, so we do have to render it. And that's what we see. Let's choose an angle where we can actually see if the surface is being displaced. And you see it's actually not displaced. That's the bump we created with the sculpt deformer. We should see lots of more details in here, in the slope for example, which we don't. And there are two parameters we have to choose now, and the first one doesn't sit in the displacement shader. So many clicks actually. So it sits in the material, not in the material, it's in the geometry of our displaced surface. So we click on the surface again, and then that's the AI standard surface. No, we want the surface, which is well, where is it? It's the polyplane really. It's the polyplane shape. So many clicks really. And here we have, under polyplane shape, we have an Arnold tab. And under the Arnold tab, you see Arnold translators, polymesh, opaque, matte, primary visibility, etc. Export if you want to export the geometry, not the shader. It's all about the geometry here. And here you have the section subdivisions. And the subdivision type currently is set to none. If we set it to what's always advised, to Cat-Clark, it comes from the Catmull-Clark algorithm, which is basically a subdivision algorithm. We don't care about it, but we just select it. And then we still don't see any real displacement here until we increase the next entry here. And if we go here to iterations 4, we see the bumps develop. So that's the first stop in order to create a displacement map. Now let's go to the shader. Example, several ways to get there. Right mouse click on the surface and material attributes, which brings us here to the file and etc. So let's go to the displacement now. Actually, this is not the displacement. Is it here? No, we're just right. This is the displacement shader, and the displacement shader has a scale, and the scale is a nice thing because currently it's set to 1. Let's set it to 3, and now watch what's happening in the render view. We have much higher deformation. Here's a little crater, for example, and here is a path to the top. And of course this is all a little bit low res here, because there is low res in our displacement map in the photograph we chose. So we must not look too closely to it or add more detail. So that's the importance of high resolution displacement shaders. If you see the thing from a distance, this doesn't matter so much. It looks like a really interesting stony or whatever mountain surface here. I like that quite a bit. But when you get closer, of course, you have to put more detail in it. Well, that's all I wanted to show you, really. And the displacement is doing something which the bump never does. The bump would never show a peak like this. The bump map just fakes 3D-ness, but this is the real displacement here. And we didn't have to change the resolution of the original geometry. It's all being done with the subdivisions in the Arnold options of the actual geometry.